Hello viewers, welcome to another new video of You Learn It Tutor. I hope you're all good. Today we'll be seeing another transformation problem. This type of a problem is very much common in the past papers and it might come in the future exams too. The diagram shows triangle A and B. Describe fully the single transformation that maps triangle A onto triangle B. So think about it. If I am now from A to B, this one. Now it means first of all we need to find out whether we need to understand whether this is enlargement or rotation or reflection or translation. In enlargement there will be a difference in size. Now from A to B, is there a difference in size? If you are looking in a different way, let's say I'm looking in a different way with a different angle, it doesn't look that there is a difference in size. So enlargement is probably not the answer, mostly not the answer. Same way, is it a rotation? Looks like it is a rotation. Most probably this one is actually this one. This vertex is this vertex. So it might be a 90-degree clockwise. So seeing from the picture, you need to first guess, you need to first have an analysis of what type of transformation this A is going through. Triangle A is going through to be triangle B. Similarly, it's not a translation because in a translation it's just transfer of space and there is no change in the shape. A is transformed to B, so there is a change in shape. It doesn't look as the same shape. And also in a reflection, basically there has to be a bit of a change. Mostly the one that is at the top becomes the point at the bottom. The one that is at the right becomes the point at the left. So this is not also a reflection. So mostly we have found out that this is 90-degree clockwise. Now for this, even if I am writing anti-clockwise, for rotation I need to figure out the center. So rotation center is, for enlargement all you need to do is just take join the vertices, but in rotation we have to, let's say this vertex and this vertex I'm joining. Also I need to draw a perpendicular bisector. Now let's say this is 1, 2, 3, 4, 5. So if this is 5 difference, 1, 2 and a half, so here basically I should be drawing a perpendicular bisector at this point. Most probably if you are drawing a perpendicular bisector, this will go through this point. This will be something like this. Also, let us join another. This point should be this point and this point should be this point. So let's say I'm joining these two vertices now. And if I am joining, let's say this is what? 1, 2, 3, 4. So 1, 2. Based on this, maybe I will, if I draw another perpendicular bisector, this might go through this point. With a scale, if you do, it would have been much better. So you see, this two perpendicular bisectors are hitting at this particular point. So this is your center of rotation, 1, 2. And once you write both the points, what is the transformation and what is the center, then you get the full mark. This is a 3-mark question. So for this, let's say whether this is right or wrong, if you want to check it, let's say based on this point, this particular vertex will have the coordinates of the vertex will be -3, 1, 2, 3 and 2. So this will be -3, 2 based on this particular center, and the same vertex is actually this vertex, we are expecting this to be 90 degree clockwise. This will be what? 2, 3. So 2 and 3. Now think, in a 90 degree clockwise, what happens to the original vertex? Both the coordinates gets interchanged, and the one at the right, after changing, one at the right gets the sign opposite. So let's say if this is xy, 90 degree clockwise will make it y minus x, and that's what happened here. Minus 3 2 became 2 3. So this particular point is actually the correct center. So I hope you have understood the question. Please go through the problem again, because for rotation we need to actually draw perpendicular bisectors after joining the vertices. So thank you very much. Stay with the channel for more videos.